talked to Carl Friston about this prediction idea in some detail. And so Friston, for those of you who are watching and listening, is one of the world's top neuroscientists. And he's developed an entropy enclosure model of conceptualization, which is analogous to one that I was working on, I suppose, across approximately the same time frame. So the first issue, and this has been well established in the neuropsychological literature for quite a long time, is that anxiety is an indicator of discrepancy between prediction and actuality. And then positive emotion also looks like a discrepancy reduction indicator. So imagine that you're moving towards a goal, and then you evaluate what happens as you move towards the goal. And if you're moving in the right direction, what happens is what you might say, what you expect to happen, and that produces positive emotion, and it's actually an indicator of reduction in entropy. That's one way of looking at it. And the point is,
you have a bunch of words in there that are psychological definitions of states. But you could say there's a prediction and error to prediction.
Yes.
And you're reducing error.
What I'm trying to make a case for is that your emotions directly map that, both positive and negative emotion, look like they're signifiers of discrepancy reduction, both on the positive and negative emotion side. But then there's a complexity that I think is germane to part of Jonathan's query, which is that, so the neuropsychologists and the cognitive scientists have talked a long time about expectation, prediction, and discrepancy reduction. But one of the things they haven't talked about is it isn't exactly that you expect things. It's that you desire them. You want them to happen. Because you could imagine that there's in some sense a literally infinite number of things you could expect. And we don't strive only to match prediction. We strive to bring about what it is that we want. And so we have these preset systems that are teleological, that are motivational systems.
Well, I mean, it depends. Like if you're sitting idly on the beach, like and a bird flies by, you expect it to fly along in a regular path.
Right.
But you don't also really want that to happen.
Yeah, but you don't want it to turn into something that could peck out your eyes either.
Sure, so that's a want.
There. Yeah.
But you're kind of following it with your expectation to look for a discrepancy. Right?
Yes.
Now, you'll also have depends on the person, somewhere between 10 and a million desires, right? And then you also have fears and avoidance. And those are context. So if you're sitting on the beach with some anxiety that the birds are going to swerve at you and take your eyes out.
Yeah.
So then you might be watching it much more attentively than somebody who doesn't have that worry, for example.
Right. Well,
but both of you can predict where it's going to fly. And you will both notice a discrepancy, right?
The motivations, one way of conceptualizing fundamental motivation is they're like a priori prediction domains, right? And so it helps us narrow our attentional focus, because I know when you're sitting and you're not motivated in any sense, you can be doing just in some sense trivial expectation computations. But often we're in a highly motivated state.
Sure.
And what we're expecting is bounded by what we desire, and what we desire is oriented, as Jonathan pointed out, towards the fact that we want to exist. And one of the things I don't understand and wanted to talk about today is how the computer models, the AI models, can generate intelligible sense without mimicking that sense of motivation. Like, because you've said, for example, they can just derive the patterns from observations of the objective world, but there's
so again, I don't want to do all the talking, but so AI, generally speaking, like when I first learned about it, had two behaviors. They call it inference and training. So inference is you have a trained model. So you give it a picture and say, is there a cat in it? And it tells you where the cat is. That's inference. The model has been trained to know where a cat is. And training is the process of giving it an input and an expected output. And when you first start training the model, it gives you garbage out, like an untrained brain would. And then you take the difference between the garbage output and the expected output and call that the error. And then they invent the big revelation was something called backpropagation with gradient descent. But that means take the error and divide it up across the layers and correct those calculations so that when you put a new thing in, it gives you a better answer. And then, to somewhat my astonishment, if you have a model of sufficient capacity, and you train it with 100 million images, if you give it a novel image and say, tell me where the cat is, it can do it. Right? So training is the process of doing a pass with an expected output and propagating an error back through the network. And inference is the behavior of putting something in and getting an output.
Yeah. I think I'm really pulling.
But there's a third piece, which is what the new models do, which is called generative. It's called a generative model. So, for example, say you put in a sentence and you say, predict the next word. This is the simplest thing. So it predicts the next word. So you add that word to the input and now say, predict the next word. So it contains the original sentence and the word you generated. And it keeps generating words that make sense in the context of the original word and additional words.
Right.
This is the simplest basis. And then it turns out you can train this to do lots of things. You can train it to summarize a sentence. You can train it to answer a question. There's a big thing about, like Google every day has hundreds of millions of people asking it questions and giving answers and then rating the results. You can train a model with that information. So you can ask it a question and it gives you a sensible answer.
But I think in what you said, I actually have the issue that has been going through my mind so much is when you said, people put in the question and then they rate the answer. My intuition is that the intelligence still comes from humans in the sense that it seems like in order to train whatever AI, you have to be able to give it a lot of power and then say at the beginning, this is good, this is bad, this is good, this is bad, like reject certain things, accept certain things in order to then reach a point when then you train the AI. And so that's what I mean about the care. So the care will come from humans because the care is the one giving it the value, saying this is what is valuable, this is what is not valuable in your calculation.
So when there's a program called AlphaGo that learned how to play Go better than a human. So there's two ways to train the model. One is they have a huge database of lots of Go games with good winning moves. So they trained the model with that. And that worked pretty good. And they also took 2 simulations of Go and they did random moves. And all that happened is these 2 simulators played one Go game and they just recorded whichever moves happened to win. And it started out really horrible. And they just started training the model, and this is called adversarial learning. It's not particular adversarial. It's like, you make your moves randomly, and you train a model. And so they trained multiple models, and over time, those models got very good. And they actually got better than human players. Because the humans have limitations about what they know, whereas the models could experiment in a really random space and go very far.
Yeah, but experiment towards the purpose of winning the game.
Yes. Well, but you can experiment towards all kinds of things, it turns out. And humans are also trained that way. Like when you were learning, you were reading, you were said, this is a good book, this is a bad book, this is good sentence construction, it's good spelling. So you've gotten so many error signals over your life.
Well, that's what culture does in large part.
And culture does that, religion does that, your everyday experience does that, your family. So we embody that, and we're all, and everything that happens to us, we process it on the inference pass, which generates outputs. And then sometimes we look at that and say, hey, that's unexpected, or that got a bad result, or that got bad feedback. And then we backpropagate that and update our models. So
could there
really
be
well-trained models can then train other models.
So the
humans
biggest
right now are the smartest people in the world.
So the biggest question, that comes now based on what you said is, because my main point is to try to show how it seems like artificial intelligence is always an extension of human intelligence. Like it remains an extension of human intelligence. And maybe the way
that won't be true at all.
So do you think that at some point the artificial intelligence will be able to, because the goals, recognizing cats, writing plays, all these goals are goals which are based on embodied human existence. Could an AI at some point develop a goal which would be incomprehensible to humans because of its own existence?
Yeah, I mean, like, for example, there's a small population of humans that enjoy math, right? And they are pursuing, adventures in math space that are incomprehensible to 99.99% of humans. But they're interested in it. And you could imagine like an AI program working with those mathematicians and coming up with very novel math ideas and then interacting with them. But they could also, if some AIs were elaborating out really interesting and detailed stories, they could come up with stories that are really interesting. We're going to see it pretty soon, like all of art,
could there be
and everything.
A story that is interesting only to the AI and not interesting to us?
It's possible. So stories are like, I think, some high level information space. So the computing age of big data, there's all this data running on computers where only humans understood it, right? And computers don't. So AI programs are now at the state where the information, the processing, and the feedback loops are all kind of in the same space. They're still, relatively rudimentary to humans. Like some AI programs in certain things are better than humans already, but for the most part, they're not. But it's moving really fast. So you could imagine, I think in 5 or 10 years, most people's best friends will be AIs. And, they'll know you really well and they'll be interested in you. And, it's
unlike your real friends.
Yeah, real friends are problematic.
They're only interested in you when you're interested.
Yeah, real friends are.
The AI systems will love you even when you're dull and miserable.
Well, there's so much idea space to explore. And humans have a wide range. Some humans like to go through their everyday life doing their everyday things, and some people spend a lot of time, like you, reading and thinking and talking and arguing and debating, and that there's going to be a diversity of possibilities with what a thinking thing can do when the thinking is fairly unlimited.
So I'm curious in pursuing this issue that Jonathan has been developing. So there's a literally infinite number of ways, virtually infinite number of ways that we could take images of this room.
Mm-hmm.
Right now, if a human being is taking images of this room, they're going to sample a very small space of that infinite range of possibilities. Because if I was taking pictures in this room, in all likelihood, I would take pictures of objects that are identifiable to human beings, that are functional to human beings, at a level of focus that makes those objects clear. Mm-hmm. And so then you could imagine that the set of all images on the internet has that implicit structure of perception built into it. And that's a function of what human beings find useful. I could take a photo of you that was the focal depth was here and here and here and here and here and 2 inches past you. And now I suppose you could.
There's a technology for that called light fields.
Okay.
So then you could, if you had that picture properly done, then you could move around in that image and see. But yeah, fair enough. I get your point. Like the human recorded data has
our biology built into it.
Has our biology built into it, but also unbelievably detailed encoding of how physical reality works. Right. So every single pixel in those pictures, even though you kind of selected the view, the focus, the frame,
right,
it still encoded a lot more information than you're processing.
Right.
And if you take it turns out if you take a large number of images of things in general, so you've seen these things where you take a 2D image and turn it into a 3D image.
Yeah.
Right. The reason that works is even in the 2D image,
the 3D
is in the room actually got embedded in that picture in a way. Yeah. Then if you have the right understanding of how physics and reality work, you can reconstruct the 3D model.
Okay, so this reminds
me. You could, an AI scientist may cruise around the world with infrared and radio wave cameras, and they might take pictures of all different kinds of things, and every once in a while they'd show up and go, hey, the sun, I've been staring at the sun and the ultraviolet and radio waves for the last month. And it's way different than anybody thought, because humans tend to look at light in the visible spectrum. And, there could be some really novel things coming out of that.
Well, so
But humans also, we live in the spectrum we live in because it's a pretty good one for planet Earth. Like it wouldn't be obvious that AI would start some different place. Like visible spectrum is interesting for a whole bunch of reasons.
right. So in a set of images that are human derived, you're saying that there's the way I would conceptualize that is that there's two kinds of logos embedded in that. One would be that you could extract out from that set of images what was relevant to human beings. But you're saying that the fine structure of the objective world outside of human concern is also embedded in the set of images.
Yes.
And that an AI system could extract out a representation of the world, but also a representation of what's motivating to human beings.
Yes.
So-
And then some human scientists already do look at the sun and radio waves and other things because they're trying to, get different angles on how things work.
Yeah, well, I guess it.
Yeah. So it's a curious thing. It's like the same with like buildings and architecture. Mostly fit people.
Well, the other.
Yeah.
And there's a reason for that.
The reason why I keep coming
But
back
it's
to
also-
hammering the same point is that even in terms of the development of the AI, that is, developing AI requires immense amount of money, energy, and time. And
That's a transient thing. In 30 years, it won't cost anything. So that's going to change so fast. It's amazing. So that's like supercomputers used to cost millions of dollars, and now your phone is the supercomputer. So it's the time between millions of dollars and $10 is about 30 years. So it's like I'm just saying it's like the time and effort isn't a thing in technology. It's moving pretty fast. That just sets the date.
yeah, but even making, let's say, I guess maybe this is the nightmare question. Like, could you imagine an AI system which becomes completely autonomous, which is creating itself even physically through automized factories, which is, programming itself, which is creating its own goals, which is not at all connected to human endeavor?
I mean, individual researchers can, I have a friend who, I'm going to introduce you to him tomorrow. He wrote a program that scraped all of the internet and trained an AI model to be a language model on a relatively small computer. And in 10 years, the computer he could easily afford would be as smart as a human. So he could train that pretty easily. And that model could go on Amazon and buy 100 more of those computers and copy itself. So yeah, we're 10 years away from that.
And then why would it do that? I mean, is it possible? It's all about the motivational question. I think that's what even Jordan and I both have been coming at from the outset. It's like, so you have an image, right? You have an image of Skynet or of the Matrix, in which the sentient AI is actually fighting for its survival. So it has a survival instinct, which is pushing it.
I was thinking
to self-perpetuate.
That's
like to replicate itself and to create variation on itself in order to survive, and identifies humans as an obstacle to that,
Yeah. So you have a whole bunch of implicit assumptions there. So humans, last I checked, are unbelievably competitive.
Mm-hmm.
And when you let people get into power with no checks on them, they typically run amok. It's been historical experience. And then humans are, self-regulating to some extent, obviously with some serious outliers, because they self-regulate with each other. And humans and AI models at some point will have to find their own calculation of self-regulation and trade-offs about that.
Yeah, because AI doesn't feel
So-
pain, at least that we don't know that it feels.
Well, lots of humans don't feel pain either. So humans feeling pain or not doesn't stop a whole bunch of activity. That's
it doesn't. The fact that we feel pain doesn't stop. us from being
regulate that
malevolent.
many people. Yeah.
Right. Right.
There's definitely people like, children, if you threaten them with, go to your room and stuff, you can regulate them that way. But some kids ignore that completely, and adults are the same
And it's
way.
often counterproductive.
Yeah. So right, culture and societies and organizations, we regulate each other, sometimes through success
In
and not success.
competition and cooperation.
Yeah.
Do you think that, well, we've talked about this to some degree for decades. When you look at how fast things are moving now, and as you push that along, when you look out 10 years, and you see the relationship between the AI systems that are being built and human beings, what do you envision? Or can you envision it?
Well, can I? Yeah. So like I said, I'm a computer guy, and I'm watching this with, let's say, some fascination as well. I mean, so Ray Kurzweil said, progress accelerates.
Yeah.
Right. So we have this idea that 20 years of progress is 20 years, but the last 20 years of progress was 20 years, and the next 20 years will probably be 5 to 10.
Right. And you can really feel that happening.
To some level, that causes social stress, independent of whether it's AI or Amazon deliveries. There's so many things that are going into the stress of it all.
Mm-hmm.
But there's progress, which is an extension of human capacity, and then there's this progress which I'm hearing about, the way that you're describing it, which seems to be an inevitable progress towards creating something which is more powerful than you, right? And so what is that? I don't even understand that drive. What is that drive to create something which can supplant you?
So look at the average person in the world, right? So the average person already exists in this world because the average person is halfway up the human hierarchy. There's already many people more powerful than any of us. They could be smarter, they could be richer, they could be better connected. We already live in a world, like very few people are at the top of anything, right? So that's already a thing.
So basically the drive to make someone a superstar, let's say, or the drive to elevate someone above you, that would be the same drive that is bringing us to creating these ultra powerful machines. Because we have that, like we have a drive to elevate. Like, when we see a rock star that we like, people want to submit themselves to that. They want to dress like them. They want to raise them up above them as an example, something to follow, right? Something to subject themselves to. You see that with leaders. You see that in the political world. And in teams, you see that in sports teams, the same thing. And so do you think
we've always tried to build things that are beyond us. I mean,
it's about, are we building a God? Is that the drive that is pushing someone towards? Because when I hear what you're describing, Jim, I hear something that is extremely dangerous, right? It sounds extremely dangerous to the very existence of humans, yet I see humans acting and moving in that direction almost without being able to stop it, as if there's no one now.
I think it is unstoppable. That's one of the things we've also talked about, is because I've asked Jim straight out, because of the hypothetical danger associated with this, why not stop doing it? And part of his answer is the ambivalence about the outcome, but also that it isn't obvious at all that in some sense it's stoppable.